The quadratic formula is a formula used in order to solve equations of the form ax squared plus bx plus c. And sometimes we get complex solutions, sometimes we get real solutions. It just depends on what those values of a, b, and c are. The part that determines whether it's complex or not is the b squared minus 4ac, the thing that's within the square root here, and it has a fancy name. It's called the discriminant. So let's use the quadratic formula in order to solve some quadratic equations. For this one here, we have 3x squared plus 2x minus 4. So we have a is 3, b is 2, and c is negative 4. So we can go right to the quadratic formula. The opposite of b, negative 2, plus or minus the square root of b squared, so 2 squared minus 4 times a, 3, times c, which is negative 4, all over 2 times a, which is 3. Now we'll simplify this. I have negative 2 plus or minus the square root of 2 squared is 4. We have 4 times 3 times negative 4. So 4 times 3 times negative 4. That's negative 48. And we're subtracting that, so it's plus 48 all over 6. Okay. I now have negative 2 plus or minus 4 plus 48 is 52. 52 all over 6. Okay, now 52, I think I can simplify that a little bit. So 52, is it divisible by 4? Yeah, so 4 times 13 gives us 52. So I can write this as negative 2 plus or minus the square root of 4 times 13 all over 6. Okay, I'm going to go back over here. This is negative 2 plus or minus square root of 4 is 2, and the square root of 13 is still in there. It's all over 6. Okay. One last step. We'll share the denominator, the 6. I'll say this is negative 2 over 6 plus or minus 2 times the square root of 13 over 6. And I can take out a factor of 2 from both of these. This gives me a 3, this gives me a 1, this gives me 1, this gives me a 3. This is the negative 1 over 3 plus or minus the square root of 13 over 3. And it does look pretty complicated. This would just be negative 1/3 plus the square root of 13 over 3. And then the other solution is just negative 1 over 3 minus the square root of 13 over 3. So these are the two solutions to this equation. These are the two solutions here. We can write it just like this though. Okay, let's do another example. This time, I believe we'll get a complex or two complex solutions. So we have a is 2, that's a, b is 3, b, and c is 5. So our solutions, we have x equals the opposite of b, -3, plus or minus the square root of b squared, so 3 squared minus 4 times a is 2 times c is 5, all over 2 times a, which is 2. Okay, let's simplify this. -3 plus or minus, we have 9 minus 40. 4 times 2 times 5, yeah, that's 40. 2 times 2 is 4. So we have -3 plus or minus 9 minus 40. Let's double check. -31 all over 4. Okay. 31 is a prime number. So we can just write this as I times the square root of 31. -3 plus or minus, let me do it in 2 steps. -1 times 31 all over 4. And this is then 3 plus or minus, square root of -1 gives me I. And the square root of 31 is still there, all over 4. Again, I'll share the denominator with both those terms. This gives me -3 over 4 plus or minus I square root of 31 over 4. And that's a good way to write it. If you want to write the solution separately, it's -3/4 plus I times the square root of 31 over 4. Put a comma between them. -3/4 minus I times the square root of 31 over 4. One thing to notice, these solutions are conjugates of each other.